Yeah, hello class. This is the second part of the video for section 3.7, rational inequalities. Okay, we go through similar steps except the step 2. Okay, except step 2. Now remember, in solving polynomial inequalities, we do the same step 1, move all terms to one side. Okay, and then here you have rational inequality, so you have to find a common denominator, unlike polynomials, and then you simplify. Then step 2, you have to factor the numerator and then denominator. And then the factor, the numerators gives you what we call the cut points. And sometimes they call this what critical points. All right. In some textbooks, they call it critical points. So this will be the zeros of the numerator and then the zeros of the denominator separately. Okay, zeros of the numerator and then zeros of the denominator. You do them separately. And then from those zeros for the numerator and the denominator, you find the intervals. Okay, so you list all the intervals determined by these cut points from the zeros of the numerator and then the denominator. Then you make a table just like we did to determine which intervals satisfy the inequality. And of course, you go to step 5, you want to make sure that if you have less than or equal to or greater than or equal to symbol in the inequality in the problem, then you have to make sure that for the denominator, because it's a rational function, you cannot include the zeros, because once you include the endpoints, it becomes undefined. All right. So remember, if you set the denominator to 0, those give you the vertical asymptotes. Okay. So in putting this in perspective, we are going to have, unlike polynomials, rational functions are not necessarily continuous. Okay, because of the vertical asymptotes and the rest. So the vertical asymptotes causes what we call put the graphs into separate branches. Okay, so the intervals on which the R does not change sign are determined by the vertical asymptotes as well as the zeros of of the polynomial, which are the zeros of the numerator. Okay, so like we said earlier, on the cutoff points, or the cut points or the critical points are basically the zeros of the numerator. That's a P of X. We have the R of X is what P of X over Q of X. It will be the zeros of the numerator and the zeros of the denominator. So here, let's look at an example where we already have the graph, just like we had it for polynomial inequality. So here is my rational function R of X. All right. Now the R of X is X over 2, X minus 2 divided by X minus 4 times X plus 4. All right. So what are the zero? There are 3 of them, right? We have X for the numerator part. We have X minus 2 equal to 0. So it means that X is equal to 2. And then the denominator, we have X equal to -3 and then 4. Okay. So -3 and then 4 will give us those zeros. So if we graph this, okay, if we graph this, we have the following graph. Now, if I want to solve the inequality, R of X is greater than or equal to 0. Okay, what would be the solution to this? What are the solutions to that? Okay, now it is above the x-axis. So the portions above the x-axis. So this part. Okay, so we have these zeros there. Okay, so you have 2, and you have 4, and then you have 3. Okay, now the interval that satisfy the inequality or the rational function, or satisfy the inequality greater than or equal to R, from where? From -3 to 2, right? And then from 4 to what? Positive what? Infinity. So the question is that, can we, at the endpoints, -3, 2, and then 4, which of them can we include because it's what greater than or equal to, or in other words, could it be what? Brackets instead of parentheses? Well, for the numerator x minus 2, which is 2, there should be brackets on what? That is fine. Okay, but for the -3 and 2, because they're in denominator, if you include 4, for example, you give this factor here to be 0. Get 4 minus 4, which is 0. And that is makes the denominator 0, and that the function is what? Undefined. So the solution will actually be from -3 to 2, and then 4 is open, it's a parenthesis to what? Positive what? Infinity. Okay, so that will be the solution to the inequality. This is what? Greater than or equal to 0. Good. Now, let's find the domain of the function. G of x is given as that. Okay, G of x is given as this. This is we have a rational function under a radical sign. Okay, now we know that if you have a function, say f of x, which is equal to what? X, the domain is where x is greater than or equal to 0. So it means that we pick what is under the radical sign, set up the inequality greater than or equal to 0, and solve it. Okay, and going through those steps that we talked about. So it means that we need to solve the inequality 8 plus x divided by 8 minus x greater than or equal to what? 0. Okay, now let's look at all the steps. 1, say move all terms to one side. So step 1 is satisfied. This is done. Okay, because all terms on one side. Step 2, it said that factor the numerator and the denominator. This is already in the factored form. Okay, so it's factored form. So factor this also done. It is done because you have all the terms on one side and it's factored, so that is done. Step 2 is also done. But we need to find the zeros. Okay, so you got to get the zeros of the numerator. The zeros of the numerator will be -8 because x plus 8 or 8 plus is equal to 0. Okay, gives me x equals -8. And then the zeros of the what? Denominator. It is what? It's just what? 8. Okay, so we have the step 1, step 2, we have the factored form, we got the zeros of the numerator and the denominator, and then we write down our intervals. So step 3, the intervals are from what? -infinity to -8, that is 1, and then from -8 to +8, and then from +8 to positive what? Infinity. Okay, so we have these intervals. Then we want to determine which of these or these intervals satisfy the inequality greater than or equal to 0. Right? So because if I have square root of 0 over a number, this is what? That's the square root of 0, and that is what? That's 0. So you have to pay attention that this radical expression was under the rational function under the radical there. You cannot have the denominator to be 0, but you can have the numerator to be 0, and that will be fine. Okay, so now we're going to go to step 4, that is do our, but let me write the function here. X plus 8 plus x, 8 minus x greater than or equal to 0. So we do step 4, we do our table. Okay, so we got a table. We have the intervals from -infinity to -8, which is one of them. The second one is from -8 to +8. That's less. And the third one is from 8 to +infinity. Okay. Then we have 8 plus x, 8 minus x, and then we have their ratio, 8 plus x divided by 8 minus x. Okay, so we want to find the sign of this. Okay, let's pick a test values. For the first one, let's use -9 or -10. We can use 0 for that one, and we can also use 9 or 10. So if you have -9 x, so 8 minus 9, it is negative. Then 8 minus -9 will be positive, so that is positive. So negative divided by positive is what? Is negative. Okay, the second one, if x is 0, 8 plus 0 is positive, and then 8 minus 0 is also positive. Then when you divide them, positive divided by a positive number, it is what? Positive. Then last but not least, 9, the 9 plus 8 plus 9 is what? Positive. Then 8 minus 9 is negative. Then positive divided by negative is what? Negative. Okay, so when we look at it, the interval, the only interval that satisfies the inequality is the middle one. Okay, so what is our solution? That is step 5. A solution, okay, which is actually the domain of the function g of x, all right, is, well, from -8 to +8. Now, the question is, these are the endpoints. Okay, look at the inequality. It was, remember, it was square root of 8 plus x over 8 minus x. This is our g of x, right? Let me write it here. G of x is the square root of what? 8 plus x, and then 8 minus x, right? So you could see that if x is equal to 8, if we include 8, the numerator will be 8 plus 16 divided by 0, which is not allowed. Okay, it's undefined. So we cannot have brackets on what? On the +8, even though we have greater than or equal to 0. But if x is equal to -8, you get 8 minus equal to 0 over 8 minus, that'll be +16. So 8 over 0. So 0 over 16 is what? Is 0. And square root of 0 is 0. So the actual solution will be what? Okay. This part will be brackets. That is on the, it will be bracket on negative for the endpoint -8. But parentheses on the what? On the +8. So that will be the domain of the function. Okay. Now, we'll look at our last question. This is similar to question homework 15 and then 16. Okay. I changed the symbol, the inequality, I changed it to less than, because I realized I've been solving all of them are all greater than 0 or greater than equal to 0. So let's make it less than equal to 0 and then see how we solve this. All right. So now let's go to go through all the steps, all the guidelines. Okay, move all terms to one side, then factor, simplify, then factor the numerator and the denominator, and then move on. So if we have this inequality, we're going to move this to the other side, -1. So we subtract -1 from both sides. And that gives us 1 minus 2x, all divided by x squared minus 2x minus 3 minus 1 less than or equal to 1. So we move all to one side. Then we need to simplify that. Okay, so let's assume we want to have a common denominator. So let's write it here. Okay, Let's write it here. We have what we got there is 1 minus 2x divided by x squared minus 2x minus 3 minus 1 less or equal to 0. So if I want to have a common denominator, then I need to multiply this over 1. I multiply this by this whole expression. So I get 1 minus 2x, okay, over x squared minus 2x minus 3. Okay, then I have 1 times x squared minus 2x minus 3 divided by x squared minus 2x minus 3. Okay, so they have a common denominator that is still less or equal to 0. And that gives me, we have one, they have a common denominator. So the denominator will be x squared minus 2x minus 3. And then you have a 1 minus 2x. And then we have negative 1 distributed over. That gives us minus x squared. And then plus 2x, then plus 3. All right. All this is less or equal to what? 0. Right. Okay. So let's simplify the numerator. Well, 1 plus 3 is 4. So that gives us 4. And then we have plus 2x minus 2x will cancel out. So that gives us the numerator is just 4 minus what? X squared divided by the x squared minus 2x minus 3 less or equal to 0. So that is why I have this. Okay, I have that expression there. So now the step 2 is that factor the numerator and the denominator. Okay, so let's do it the next step. All right, so now we got 4 minus s squared, right? Divided by s squared minus 2s minus 3. Now look at the numerator. That's a difference of 2 squares. We cannot see that a squared minus b squared is always equal to what? A plus b, or a minus b, and then what? A minus b. A plus b times a minus b are the same as a minus b times a plus b. So this is the same as 2 squared, all right, minus x squared. So the numerator is actually 2 minus x, right? And then 2 plus x. Then we need to factor the denominator. Okay, luckily, all right, the coefficient of x squared is 1. So we put x there and then x, 2 factors of negative 3. Okay, negative 3. That when you add, you get to a negative 2. Of course, that would be negative 3 and then 1. So you put plus 1 and then minus 3. Less than or equal to what? 0. So that is why I have what? This expression there. Okay, so then we get the zeros of the numerator and the denominator. So if you pick the zeros, 2 minus x equal to 0, meaning what? X is equal to 2. Then you have 2 plus x equal to 0 will give me x is equal to minus 2. So you have plus 2 and minus 2 from the numerator. And then the denominator, you have what? Negative 1 from the factor x plus 1. And then positive 3 from the factor x minus and minus 3. All right. So these are the zeros. There are 4 of them, plus or minus 2, negative 1, and then positive 3. Okay. Now, when we have this is a 4, it divides the real number line into what? 5 intervals. So we have it from negative infinity to negative 2, negative 2 to negative 1, negative 1 to 2, 2 to 3, and then 3 to what? Positive infinity. So we have our step 1, step 2, step 3 done. Step 4 is to get the table, okay, which we do in the next. So we have the table or the diagram. So I have all the intervals here For -2, negative infinity, all the 1, 2, 3, 4, 5, right? Let me change the color, right? So then I'm going to multiply the numerator and the denominator, find the sign. Okay, let's pick a testing value for each of them. Let's use -3 for that one. We can use negative 1.5, 1.5 for that interval. We can use 0 for that interval. We can use 2.5 for that interval. We can use 4. All right. So if I have -3, -3 have 2 minus -3 will give me positive, right? And then 2 minus 3 is what? Negative. So this is what? This is negative. Then I go to the next, the denominator, which is x minus, so -3 minus 3 is what? Is this negative? Then we multiply by -3 plus 1, which is -2 by negative. So that is also positive. So then if you divide negative by positive, you get what? Negative for the first one. Okay, now if you have -1.5, you got 2 minus 1.5. That will be positive. So you have positive there. And then 2 minus 1.5 is also positive. So that makes this what? The numerator positive. And then the denominator, you have negative 1.5 minus 3 is negative. And then we multiply by negative 1.5 plus 1, which is negative. So that makes that what? Positive. Then of course, most positive divided by positive is what? It is positive. Okay. Now let's, if we x is 0, you have positive times positive is positive. And then if x is 0, you have negative times positive is negative. Then positive divided by negative is negative. Then we go to the third one, 2.5. Okay, 2.5x, 2 minus 2.5 is negative, times 2.5 is positive, so that gives me negative. Then if you go to this denominator, you have x minus 3, that is 2.5 minus, you get negative, all right? And then you are multiplying it by positive. That is what? That is negative. Of course, negative divided by negative is what? Is positive. And then finally, if we x is 4, 2 minus 4 is negative, and then 2 plus 4 is positive, right? So that gives that this is negative. Then you have 4 minus 3 is positive, and 4 plus 1 is positive. So this is positive, and then you get negative divided by that is what? Negative. So as you can see, which intervals, okay, which intervals satisfy the what? The inequality. Okay, it is less than 0. So it will be the first one, the third one, and then what? The last one. So these intervals are what? Are all, they satisfy. However, our inequality, we are supposed to find the expression that it is what? Less or equal to 0. So what happens at the endpoints? So again, if you look at the denominator, the zeros that come from the denominator, which actually the vertical asymptotes, cannot be included. There should be parentheses at the endpoints. But for the numerator, the zeros from the numerator, they should be what? Brackets, because of the inequality less or equal to 0. Therefore, in this case, we will change this what? The solution will be, this will be brackets on that, brackets on that, and then -1 is the 0 from the denominator. So if you include -1, it will be 0 in the denominator, which is undefined. And then 3 again from that factor, that's 0 from that. So therefore, it cannot be 3 either. So what is the solution? When we write down the solution, this is what we got. We have this and the 2, and that's the solution to the what? The inequality that the rational function that we have, which is less or equal to what? 0, or the one we had, 1 minus 2x over x squared minus 2x minus 3 less or equal to what? 1. Okay, and then this is the graph that confirms that. Okay, so that is the end of this video, and I hope this is helpful. Thank you.